Welcome back to another episode of AI Basics brought to you in partnership with our friends at Google Cloud. Google Cloud just published a fantastic report. It's called The Future of AI Perspectives for Startups. It features insights from 23 leading AI experts. And today on the program, we're delighted to have Amin Vahdat. He's VP and GM of Machine Learning and Cloud AI over at Google Cloud. Amin Vahdat has worked on scaling the internet for decades. And we're going to talk today about TPUs, GPUs, just how the infrastructure is scaling, Amin. But I wanted to do it from the application layer backwards.
Yes.
Last night, I had my high fidelity headphones on. I was listening to some groovy music and I was like, tell me more artists like Bob Dylan and Mark Knopfler. Give me an analysis by decade. And I realized I had sent Google Gemini's deep research to do essentially what would have been like a PhD, thesis.
Yes.
And it returned it. And I would have never known about this music. My God, the joy that gave me finding new artists. And this is a silly example, but when I clicked on like show your work and I watched it work, I was astounded at how many threads were fired at once. So I want to help people conceptualize when you do a deep research and you switch your model to something like that, what's going on in the background on the hardware layer going through, I think, what is the largest cluster of computers ever assembled, which is Google's cloud?
It's a great question. And I mean, I'll start to take one step back that, today when you do a, quote unquote, normal web search, actually somewhere between 1,000 and 10,000 standard computers, putting aside any AI mode or AI overview or any of the new features there, they're essentially collaborating together to comb over an index of the entire internet to give you good answers for your point query. Now, the example that you're going to, though, it probably is the same 1,000 to 10,000 standard servers, so that we've grown to love over the past couple of decades. But in addition to that, there is now a incredible pool of custom accelerators at Google for deep research. It's going to be our TPUs, our tensor processing units. And essentially think of these as being able to pack in the general purpose computing power of 100 servers.
Wow.
Into one chip.
Incredible.
Now compose those out for your queries. I'm going to give you an estimate. There were probably 256 of these chips, each packing in 100 servers worth of compute, coordinating together. So that would be, again, do the simple math, right? We're talking about tens of thousands of server equivalents doing the work to answer just a part of your question. And so for your specific example, the amazing thing is, and as you said, show your work, it's not just one query. It's not just one request and response. It is iterating in real time. So there might have been, depending on the complexity of your request, 10, 20, or 100 subqueries that have to get run and then composed together to give you a really good answer.
Wow. So let's talk about how that data moves, because I think this will inform what founders will think about building. So I'm trying to sort of open up their minds a little bit of just what's capable today. We'll get into what's going to be, what we'll be capable of next year and maybe in 2 or 3 years, so we can skate to where the puck is going. But this is kind of mind-blowing how much compute you can put to work and at such an affordable level that it's almost like, when you and I started our career, we were talking pre-show about floppy disks and stuff like that. If somebody told you like you have infinite bandwidth and infinite storage in the 80s or 90s, our minds probably wouldn't be able to comprehend that. So let's think about how this data moves around, how quickly it moves around. We know now that there's, we're talking about thousands and thousands of what would be web servers at your disposal answering queries. How should a developer or even a founder who's a, quote unquote idea person comprehend how to take this amount of compute, the amount of data storage and the bandwidth we have available now and turn that into a product?
Yeah.
Is there like an exercise we can do to open our minds to these possibilities?
The exponentials here are astounding. And I did enjoy our pre-show conversation. I mean, an anecdote I'll share with you that you're well aware of, but in the 80s, and early 90s, when the internet was in its early stages, the overhead of you signing your name to your email in terms of bandwidth was noticeable. Like, in other words, hey, don't type too many characters because that might hurt the internet connection. Like, don't sign the Jason, don't sign Amin. Now where are we, right? Real-time video 7 streams to your house in real time. So really what I would say to founders is imagine the transformation and the way that things are advancing, whether it's bandwidth, whether it's storage, whether it's raw compute capability, probably your imagination can be achieved. Now, in a particular day or month or year, you're going to have to think about making it efficient, but it is just exploding at really levels I've never seen before.
So a lot of the power now is making its way into inference.
Yes.
For folks who don't know, you're using a lot of the infrastructure to build a model. Okay, people are building models all over the place. You can go on Hugging Face. You can see all the incredible activity there. But inference, being able to process queries faster and faster in real time, how has that changed just in the last year or two? And then how will that change in the next year or two? Because, we were sitting here, I don't know, it was 18 months ago, and back to bandwidth, it was writing a response. I'm moving my finger slowly across
left
the
to
screen.
Right. Left to right.
Left to right. Like, we haven't had that experience since dial-up modems. Now it's just boom. It just shows up. The entire 1,000 words just appears on your screen instantly, which is kind of mind-blowing. But when we do these deep researches, you're watching it work, and it's working in parallel. It's putting everything together. It might take a couple of minutes, and now there's just like really neat feature where it's like, hey, we're working on it. We're going to send you an alert, which I think is just awesome, like a great little user feature there. So talk to me about inference, how that's changed in just the last 18 months. And then maybe we put our, binoculars on here and where it will be in 18 months.
Yeah, it's a great question. I mean, I call the moment that we're in right now the age of inference. 2025 is the year of inference. And exactly as you said it, we've moved from the primary focus being about training and building the models to shifting that focus to serving the models and really making them super useful for our customers across the world. And as you said, we went from you being able to almost read faster than the output happened to it appearing instantaneously. So that what that means now, though, is we're making the jobs harder. We're doing research. We're doing lots of queries. Sometimes it might take minutes. It's a time right now where people are really focused on efficiency. I mean, I can tell you it would not be uncommon here at Google for us to make things twice as fast in 3 months.
Wow.
And then do it the next 3 months, and then do it 3 months after that. And as you know, with exponential compounding, all of a sudden you have 10x, and all of a sudden you have 20x, and et cetera. So it's just, and then the hardware gets faster than 12 months after that. So it's not just the software work, it's the hardware work, it's the management. So really think in terms of the capabilities of these models totally taking off, and a lot of the work shifting from training time to thinking time, inference time, as you said, in response to your particular question.
What are you seeing from startups right now and even enterprises in terms of the jobs they're throwing at this massive amount of infrastructure that's being built at a blistering pace?
Yes.
On, in some cases, what we used to do commodity hardware, now we're doing sort of premium hardware, but it'll become commoditized again, I assume. What kind of jobs are people throwing at the hardware now? And are there instances where they're overwhelming it or, otherwise hitting a breaking point? Because I haven't heard from any startups. The bottleneck is now, infrastructure and availability. That was like the discussion 12 months ago, and now I don't hear it anymore.
I think that as I said, things are getting so much more efficient so quickly. I think infrastructure remains at a premium from the perspective of there's just so many companies out there with so many great ideas. But what we're seeing right this moment is around productivity, and productivity starting with engineering productivity or employee productivity. The hottest areas right now are around code, software engineering. And in other words, the kinds of things that people are now able to do. I mean, the anecdote I like to share is somewhere around 12 months ago, these models had trouble counting the number of R's in strawberry. Right? Yeah. Like ask the model how many R's in strawberry, and some of the models would get the answer wrong. Now they're generating working code, and they're actually finding bugs in real complex systems. So in other words, the productivity boost for engineering disciplines, science disciplines, math, et cetera, really unbelievable. So the capabilities of these things are just taking off.
So let's take a little detour here into development. Startups have been constrained by a couple of things over the last couple of decades, and I've been investing in them for just over a decade. But was building them and reporting on them before that. And in the early days, getting the money together, $3, $4, $5 million to launch a product, and time. These were blockers. It took $3 or $4 million and let's call it 18, 24 months to get your product to market.
Mm-hmm.
Cloud computing came out. People started working remote. There were more developers, but still developers became the blocker very quickly after we had cloud computing. Are we going to see what happened with racking and stacking servers as the blocker? Then the blocker became the talent, the developers. Is that blocker going away? Do you believe in this vibe coding moment where the 96% of humans who don't write code, some percentage of them are going to be able to write code or speak English and have code written? Is that actually going to happen, and to what extent?
I think more people are going to be able to write code for sure, but I think that actually it really think of it as not needing fewer developers. It's multiplying the productivity and capability of the developers. Your analogy is spot on. In the end, we were limited by racking and stacking servers. Cloud computing came along, and all of a sudden, near infinite capacity became available to startups. Today, though, probably where we're constrained actually across the board for talent, whether it's large company or startup, is the really transformative engineering talent.
Got it.
There's a finite set of them. Now, if we could make them more productive, which is the goal, it's going to be incredible because now you're not going to be limited by finding those people. You're going to be limited by your imagination.
Which is pretty crazy. I want to talk, brass tacks on pricing and costs. We're obviously seeing a lot of people standing up a lot of hardware and a lot of compute. How is the pricing dropping for, the simple tasks, that this hardware can kind of do queries, can do deep research. It seems like I don't know what percentage the cost has dropped each of the last, say, 2 years, and then where you expect it to drop over the next 2. But for things like storage, it seemed like storage would drop 5% a year.
Yeah.
Sometimes 10. It wasn't like some incredible pace where you went from a 1 terabyte hard drive to a 50 terabyte hard drive. In fact, that doesn't exist as a concept yet. I think that maybe we're up to 14 terabytes. I don't know. People stop counting, which is a good indicator of how fast even that is moving. But how fast is queries, tokens, how fast is that plummeting in cost?
Yeah, so this is something that we're proud of at Google. In other words, there have been some external studies on this recently where we are really driving the frontier in what we refer to as the unit cost of intelligence. And so what I mean by that is you pick your quality target. We probably have a model that hits that quality target. How much you pay normalized to the quality at Google for our models is at that frontier where you really can't push beyond it. So whether it's the lower cost, fastest models to the higher cost, most highest quality models, we're leading there. And it's because we are, as I said, 2x efficiency improvements in 3 months is not uncommon. We're, of course, passing all those savings on to our customers. So it's not 5% a year. It might be 300, factor 3 reduction.
Oh my God.
In a year.
It's so interesting because we did have startups who were like, I don't think I can do that. And do that means some function, store this many videos, let people do this many queries, et cetera. Again, 12 months ago, 24 months ago. And that question has stopped when they come talk to their investors. They're not like, can we get another $1 million because we're going to spend another $100,000 a month on this? They're now not able to utilize the infrastructure as fast as it's being built out or made more efficient. That's a very have you ever seen that in our careers as technologists? It go from the infrastructure being the blocker to the idea people and the dreamers not being able to utilize the infrastructure, and it just flip in 24 months.
Not at this level. I think that's sort of back in the heyday of the early days of the internet, where actually you were talking about hard drives, even servers. There was a time where, as you remember, 12, 18 months pass, things went down by a factor of 2. Amazing, right? This was the heyday of Moore's Law in 2098, et cetera. Today, though 12 months pass, it's a factor of 10, right? So, and humans aren't very good at thinking in terms of those massive exponentials.
Well, physics is not exponential, in the human experience. Like if you became a faster runner because you trained every day and you perfected your diet and you had the greatest trainer in the world, you'd be shaving your 12-minute mile to 10 to 8 over, whatever number of months or years to do that. You're right. We don't actually think of we can't conceptualize these things. But one way to think about it is to look backwards at what happened during the period you're talking about. And during the period you're talking about, I remember it very well because Chad Hurley was doing YouTube.
Yes.
And the price that you would pay for having a video go viral on the internet was whoever was hosting your video would turn off your server because you had used up your bandwidth allocation. So posting a video meant you got a $3,000 hosting bill, you maxed it out, they turned it off.
Yes.
So it was this whole concept that video hosting had to be paid. Then there was this little company, Google, that was like, hey, maybe we should start a second product. And Lori Park was like, hey, I got an invite for you, J. Cal. Check out this Gmail. You get 3 invites yourself. Those 3 invites became worth like $1,000 at the peak because there was, I don't know, what was the first Gmail storage? 5 gigs of storage? It was something crazy at that time. Maybe it was 10 gigs.
At some point, they said infinite storage, right?
And then at some point, again, infinite. Flickr.
Yes.
It's an incredible photo sharing app. If you just pause for a second as an entrepreneur and realize Gmail, Flickr, YouTube were not considered viable businesses because of the cost.
Exactly.
And they had to charge users. And so they were gated by this thing. And then a bunch of entrepreneurs were like, you know what? We're going to go unlimited and let's see what happens. And everybody thought YouTube wouldn't be fundable as a startup. And I think we know how that sort of went. So we can actually think about that ourselves. Yeah, I'm looking it up right now. 1 gigabyte. April 1st, 2004. I remember Lori giving me my invite back then.
That's
1
amazing.
gigabyte.
That's right.
It was crazy.
You thought it was an April Fool's joke. It wasn't.
It was launched, yes. I think it was April 1st when it was launched.
Exactly. It was.
And the interesting thing is I'm name dropping here like crazy, but I remember talking to Larry and I said, how can I delete emails in Gmail? He's like, you just archive. And I was like, wait, what do you mean? Like, what does archive mean? It's like, well, you just put it away, but it's still there. And I was like, that doesn't make sense. You either delete it or you keep it. He's like, no, this archive, new thing. And I said, no, I like to delete them. If I've read it, I've processed it, it gets deleted, then I don't have to worry about the storage. And he's like, you're not going to have to worry about storage anymore.
Yes.
Just archive it. And then he was like, why are you putting things in folders? Because I was showing him how I was using Gmail. I was like, just don't put it in folders, just search. You're wasting your own time. And you think about how prescient that is. That's how you have to think as an entrepreneur now.
Yes.
I'm trying to get at what are businesses that are constrained?
As I would say, as an entrepreneur, when you are saying this is impossible, actually write down the equation that leads you to think that. And then divide it by 10. Divided by 10. Divided by 100.
Yes.
And then is it still impossible? And maybe it is, even when you divide by 100, because probably in 2 years, you get to divide it by 100.
Yeah. So what is Google doing in the TPU space? You guys created this concept, correct? Like these were papers that came out of, I believe, DeepMind or another unit. I don't know the history exactly.
Google Brain, that's right, Transformers.
Right. So maybe you talk a little bit about the history of Transformers here, and then what Google is doing with TPUs and why that's going to change compute in some major way over the coming years.
Yeah, it's a story I love. And I think that it goes back to pre-Gen AI for sure. 2013, we did this thought exercise that said, and as Larry and others, our founders, are wont to do, there was this question that Jeff Dean, currently our chief scientist, formerly senior fellow, one of our leading technical folks, he asked this question: what if every user of Google in 2013 wanted to interact with Google via voice for 30 seconds a day? Right, the voice recognition would then need to run in our data centers for 30 seconds. It turned out that we would need to build 2 more Googles just to support that one use case. 30 seconds of voice. And as you noted, Google's already a pretty big infrastructure. So it's not like we were starting from a small base. We had one of the largest infrastructures in the world. We would have to triple it to support this one use case. Now, it turned out, though, that the operations needed for voice recognition were very predictable and regular, very large matrix multiplications. And so we realized that that CPUs only had so much efficiency in them. For general purpose central processing units could only go so far. So we essentially then invented the tensor processing unit that could do matrix multiplications 100 times more efficiently, the work behind voice recognition, than a general purpose computer. We built this very quickly, deployed it, and we enabled a use case that wasn't possible before. In other words, what we were really excited about is we made something that was impossible possible. And this wound up going at scale for lots of different use cases. That was the serving inference case that we talked about. It went to training. It then at least partially contributed to a breakthrough like transformers because we had so much computing power available to us. And that was a real enabler. It's taken off. We've had 7 generations of TPUs since then. And each one is not just 5% better than the last. This current one, our current TPU pod's 10x more capable than the previous generation TPU. Like, again, not just 5%, 10%, 15%, or even 2 times, 10 times. Right. So again, it's just exploding.
It's so crazy to think about just when and this is one of the great things about, companies reaching 1 billion users. And listen, a number of companies have done it. And I think Google has 6 products that have reached 1 billion users each. Gmail, Search, Chrome, Android, YouTube. What's the 6th? Has Docs? Has Google Docs and that suite hit 1 billion? I don't know.
I don't have it at my fingertips, but I think
there's one more.
Many of those, by the way, are at 2 billion. In other words, talk about doublings. It's really continuing to take off.
And so this is where, you do hit a roadblock because you're not just releasing something to 10 million or 1 million or 100 million people. You have to actually solve it for the 2 billion people using those really interesting products. William Gibson said something really interesting in one of his books. The street finds its own use for technology, right?
Exactly.
We build things as technologists. It goes out there and then they decide what's going to happen. What are you seeing out there on the streets? You guys get a unique view since you're providing to, I guess it's low millions of startups or, enterprises now with these tools, and on consumer basis, billions. What are you seeing people do that you didn't expect, or that is just kind of weird, odd? That's what I look for as an entrepreneur and as an investor. I look for those projects that people go, non-consensus, never going to work. Why would people need a meditation app? We invested in Calm. Nobody needs their own personal driver. You're doing a car service company, Uber, a stock trading app that doesn't charge people, Robinhood. Like these, Airbnb we weren't in, but that was a weird one. Millions of people going to sleep on people's couches. What are you seeing out there that's weird, odd, or otherworldly? You don't have to name the company, but just things people are doing with the tools.
Yeah, I don't know if I see a lot weird. I see a lot exciting. And I would say that the big thing that I see very exciting is how things are progressing with agents. In other words, now to your point of, hey, I'm going to come back and give you an answer in a couple of minutes. These agents are now able to actually invoke code, perhaps interact with other agents. So the scope of what AI can do is going, again, far beyond left to right, to not just I'm going to generate lots of answers, but I'm actually going to take action based on some of those answers on your behalf.
That's going to be fun.
Yeah, exactly. And so I think that this is going to be more in the early, but not so early stages of that. I think that we're going to see these agents really explode, and the creativity behind them is also really, really heartening.
I am studying everybody in our venture firm, on our podcasting teams. I study what they do that's repetitive. And I say to them, ADD, automate, deprecate, delegate. Like,
well put.
Yeah, is there a reason we're doing this? Let's just have that fundamental question. If we're not doing it, just deprecate it. Okay, now we're left with can we automate it or can we delegate it? When we delegate it, we'll use an Athena assistant, somebody in the lowest cost place in the world, where they have great college educated people who can do it, or an outside firm. Delegate our accounting, legal to outsourced other firms. So then that leaves automate. And really interesting how some of the young people have working for me have got their heads around this already.
Yes.
And the simple thing, I'll give you but one example. We have 20,000 people apply for funding.
Wow.
Crazy. It's second only to Y Combinator's program. There's a lot of people coming in. They send us a bunch of information, and then we have literally 7 researchers sit there, full-time people, and categorize the startup, make sure that what they tell us they're doing, it's a SaaS company, it's a marketplace company, 1 founder, it's 3 founders. And I have a system if they have these 13 qualities, that's what I'm up to. These are reasons to get excited or, maybe get more curious about the startup. So we're building an agent now, and we're kind of architecting how do we get as clean information in clean up the information we have, check it with other sources, look at other competitive startups, and build the dossier of this startup. Basically the deal memo. It's actually getting close, which means we can process more companies and not miss companies, which is really sins of omissions in venture. If you miss Google, you miss YouTube, you miss Instagram, whatever you miss defines your career. And so how close am I to having this associate agent?
A supervised associate agent like this, you're very close. And in fact, it's not just you give it the 13 categories that you're interested in. It'll come back to you and say, you know what? I think you might have missed 3.
Ooh.
And
yeah. Blind spots, right?
Yeah. And I looked back at all the successful deals you've had and the less successful deals you've had. Here's what I found that you might not have thought about.
What I love about that is, the AI is going to be brutally candid.
Yep, exactly.
There's not going to be like, I wonder if this is going to hurt his feelings that like we actually had this incredible company, apply and we missed it. Somebody might not tell me that because they don't want to make me feel bad. Yeah, it's going to be like, hey, dummy, you missed it.
And here's why.
Yeah, because there's a really good book, Super Forecasting. I don't know if you ever read it, but basically tells you how to become a forecaster. And one of the key things is writing down why you made the decision, right as you're making the decision and after you've made it. So if AI can just bring us the stuff, tell it the decision it would make, and then we make our decision, the reinforcement learning that could occur.
Exactly.
Wow.
Exactly.
But we're only in the second inning of agents, you think, if it was a 9-inning game?
First or second, for sure. Yep.
Yeah. First or second is where I would put it. Yeah.
Yep.
Listen, this has been amazing. I got to have you on the pod again.
Would love it.
Anytime you got like 3 or 4 really interesting use cases that you guys discovered, come back on and let's break them down. This has been amazing. Thanks again to Amin Vahdat for joining us here on the AI Basics series. Go to thisweekinstartups.com/basics. You'll see all the basic series in one place. For more insights, take a minute, learn some more. Go to Google Cloud's Future of AI Perspectives for Startups report. Let me give you the URL. It's also in the show notes and everywhere. goo.gle/future of AI. That's that Google short URL, goo.gle/future of AI. You're going to get predictions, real world examples, startup advice, and you're going to discover what the top AI leaders have to say about the future of AI and its impact on your business. Thanks again for listening, and we will see you next time on AI Basics.